So welcome back. Today we're going to take a look at persistence. It's a really important idea in programming. So far, all of our programs have worked great. Your programs have worked great, right? While you run it, but then, of course, when you're done, you turn it off. It has no memory. You turn it off, and all the work that you've done in your program is gone. Well, of course, we want to have some sort of persistence of data between runs of programs, and that's why we have file access. So we can write stuff to files, we can read stuff from files, we can do some other interesting things. Of course, we can even do things like databases. But for now, we're going to keep it relatively simple and talk about the main ways to read and write from files. And then from that, we'll start looking at sort of a prototype of what your final project might look like. So let's begin by writing a program that saves information to a file. So here I have a program, and we'll see how it works. But what I'm going to do right now, I'm going to go ahead and I'm going to compile it and run it. And if you look right now, you will not see anything on my desktop called poem.txt. I know my desktop is messy, but it's not there yet. Now, as we run this program, it doesn't seem to do much. But if we look around on the desktop, and I'm sure it's there somewhere because this thing is a mess, we will see poem.txt show up. There it is. Poem.txt. Let's open it up. 'Twas brillig and the slithy toes did gyre and gimble in the wave. It's a very weird poem by Lewis Carroll. All right, super. So we can definitely create a program that can write text. Well, this is interesting because then you could make like your own little notepad or something, right? You could do all kinds of interesting things. Let's see how this works exactly. Okay, so first thing is that now that we're writing things out, we need to look at the java.io library. IO stands for input and output. And it's got some really important techniques and mechanisms for us to write input and output. Well, I guess that makes sense. So we'll be importing the java.io, and I'll show you the main things we need in it in just a moment. Here's my main, nothing surprising there, and then here's the constructor. Now, it won't surprise you, I suppose, that working with files can be extremely hazardous. So we've done exception handling, right?
Yes.
Yes, okay. And so you can imagine that exception handling is going to be pretty important in a situation where we're writing files to disks. Because what happens if I have my program sitting on, I don't know, a read-only disk, a CD-ROM or something, and I try to write a file to it? Well, it won't work. Or if the drive is full, or if I try to write to a drive that's removable, a USB that's been taken out or something. And so there's lots that can go wrong when you read and write files. And this is why whenever you're doing any kind of file I/O in Java, you're required to put an exception handler in place. So you are not even allowed to compile this code if it's not inside an exception handler that looks for an I/O exception. That's actually really, really good idea because now we're trapping for some of the problems that we think might happen. So, okay, cool. So the first thing we do is we write an exception handler, try catch I/O exception, and we'll end the try. Now let's take a look at what we're actually doing in here. Now we have in Java a mechanism called I/O streams. Now the way those work is really kind of clever. And it's kind of like this. You have, you see a hose, right? And you have the hose and you take it and you can water your garden. Okay, that's terrific. It's a very basic thing. But some of us have really fancy stuff on our hose, right? You can take and you can put a little thing on the end of the hose that's got a little sprayer so you can spray the garden down, right? And it feels like rain to the happy little flowers. Or you can take that off and put another thing on it that you can use to clean like a car, so it has like a scrubber and stuff, or maybe something with a big long handle. So you have this basic device which is attaches to the water pressure, and then you can change what sorts of things you put on top of it to solve different kinds of problems. Does that make sense? The same thing is happening here with our I/O streams. So just like we think of the hose as a stream of water, we're thinking of an output stream as a stream of data. So we're sending some data out somehow. So there's a couple of kinds of streams that we use in Java. Here's the basic approach. First, we have a file writer, and that is a thing that connects to a file on the desktop. What's really cool about this is different operating systems do this in different ways. And in Java, we don't care. We do it the Java way, and then Java quietly takes care of making this work on whatever operating system we use. I'm pretty sure I wrote this originally on Linux. I'm running it right now on a Mac, and several of my students have done it on Windows. I don't have a Windows machine at home, but I've done it on Windows at work. So, okay, so this creates a file. So this makes a connection to a file, and there's two things I did here. I gave it a name, poem.txt. Now, since I didn't specify where exactly it's going wherever the Java program wants it to go. Now, you have to be a little careful about this. If I am compiling here in Dr. Java, which is simple, or from the command line, it puts it in the same directory. If you're using an IDE like Eclipse or NetBeans, the things may not be put where you expect them to go. So you got to be a little bit careful about where exactly your files are being placed. You may have to do a little detective work. And this Boolean tells me whether I want this to be overwritten or appended. So false means, hey, if it's already there, kill it right over the top of it. If it isn't there, just write it. Okay, so that's how I'm setting up the file. Now I have to tell the program how to connect to the file. And so the file system needs this file writer. That's what's going to be connected to the operating system. And the print writer is what's connected to my program. And so a print writer output gets a new print writer based on the out file. Now here's the interesting thing. This seems all a little bit weird, but you've been using a print writer all along. Because you know when we do system.out.println, well, system.out is a print writer. So this is just another way of making a print writer. And once we've done that, now we can write to this output exactly like we would be writing to the screen. So rather than saying system.out.println, I just say output.println, but it's really exactly the same thing. The only difference is this time, the text does not go onto the screen, the text goes out to a file somewhere. Oh, cool. So I can do print lines, I can do printfs, I can do whatever other kind of printing I want to do, just like I'm writing out to the command line, but this time it'll be sent out to a file. Okay, that's pretty good. Now, one more thing I need to do is I need to close output. I need to tell it, hey, I'm all done writing to the system. And the reason you need to do that is that we're actually dealing with actual hardware here. So hard drives are very, very slow compared to computer speed. And so when you tell the computer to print something, it doesn't always immediately print it. What it often will do is put it in a little separate buffer somewhere. So it puts it in a piece of memory, waits until that memory fills up, and then writes all of that to the drive. Well, this close mechanism says, okay, I'm done. Seriously, write it all to the drive. That's important because, you know, if you're halfway through writing, you think your program has written data, and then, you know, your computer gets eaten by King Kong or something, then you could lose that data. It might not actually have been stored where you thought it was. So you want to make sure you do the close to force that data to be saved. Okay, so now we have our IO exception. We'll just catch it. We'll do the most obvious thing. Just, okay, if there was an error, tell me what the error is. At least I'll know what it is. Okay, and that is it for this class. Well, let me delete this file. And we'll try it again, see if it works. So, trash. We'll run this again and see if it makes poem.txt. Run. Come on. It's around there somewhere, I'm sure of it. Yep, so there it is. So, pretty cool, huh? Now, of course, if we want to write a file, that's only half of the picture. The next thing we'd like to be able to do is read a file. I do want to make sure it showed up on my very messy desktop because we're going to read it next. Well, we'll find out, I guess. Let's run it one more time. Okay, so it's there somewhere. Now, let's talk about how do we read a file. It's similar, but not exactly the same. So as always, all these examples are on Blackboard for you. You can look them up. Save this as readfile.java. We're going to open up poem.txt, but this time, just to prove that we're doing something different, we'll open up and read it as if we're a surfer. I'll compile. And run. 'Twas brillig and the slyly toves, dude. Did gyre and gimble in the wave, dude. All mimsy were the Borgrove, dude. And the mome wrath outgrave, dude. Okay, I don't know. Do they do that dude thing in Spanish? I don't know. Probably not. But so this silly program did the same thing. It opens up the file, reads its data, and prints it out. And of course, we're typically going to do more interesting things than that. But if we can do these two things, then we can store data. We can store data so that between two runs of the program, we can have access to the same data. And more interestingly, we can take that data, send it to somebody else, and they can run their copy of the program with our data. And of course, this is the fundamental idea behind, word processors and spreadsheets and all the main kinds of programs that you're going to run. I do not want to install Mac Sierra. Thank you. Oh, did it just try to do it? Oh, dear. Okay, we're going to see. It may try to install this software in the middle of things. I was trying to make that go away. All right, so let's read this and see if we get interrupted. So import java.util. Import java.io. So the java.io we brought in. Now java.util we use a lot, right? Because that contains the scanner. Well, we love the scanner. So let's see what's going on. Read file, there's the main, not too shocking. Once again, you'll see that we do have a try catch block because every time I do file IO, I need to be watching for exceptions. Now, this looks almost the same as the read, but it isn't quite. It's a little bit different. Here, rather than having the file writer and print writer, in read file, I have two other objects. I have a file and a scanner. Okay, well, we'll see how that works. It's basically the same thing. So the file, this is a file for opening. We're doing a mechanism called sequential file access. And what sequential file access means is when I open up a file, I can read a stream of bytes from it, or I can write a stream of bytes to it. I can't do both. I have to do one or the other. And then I have to close it and reopen it if I want to do the other thing. Sequential file is pretty easy to work with, so we're going to go with it. The difference between the read file and the file is this is intended to be input. So I'm opening a file for input. Now it's the same file, so I'm opening up poem.txt, but this time I'm going to be reading stuff in from it. All right, now you look at line 12, and it's interesting because we've done this a million times. Scanner input. Wait a minute. This is not exactly like we've done it before, is it? Because before we said scanner input gets new scanner system.in. Well, if you look at the documentation for the scanner, it turns out that not only can you connect it to system.in, but you can connect it to any file. Okay, and so what we're doing now is we made a file, we're connecting the scanner to the file, and just like we already knew how to write to a file because it was how we wrote to system.out, we can make a scanner based on a file, and we can read it just like we read from the input. Now, we typically don't read it exactly the same because when we're doing interaction with a user, it's more interactive. When we're reading from a file, we do it slightly differently, but the same thing is still true. So this is still the scanner that you know and love from reading from the console, but we're going to read it a little differently. The problem is we don't necessarily know how long the text file is. So typically you'll read input with a while loop. The good news is Java makes this quite easy. While input.hasNext. So the scanner class has a method called hasNext, and what it means is there's another line. So as long as there's another line, what do? Okay, well, we grab it, system, our input.next line. So we'll print out input.next line. Now, just to be funny, I put dude at the end. And then we keep doing that until input has next is false. That means there's no more lines. We're done. Oh, okay. So when you're reading a file for input, you're going to tend to use a loop because you don't know when you're done. When you're writing file for output, you might use a loop, you might not. But when you're reading a file for input, you pretty much always use a while loop that's structured something like this. All right, we're going to catch an I/O exception and just print out what happens if there's a problem. Does that make sense?
Yeah.
Okay, good. There's variations of this. Sometimes you'll see what's called comma-separated values files. A CSV file just is plain text, but use some delimiter to separate things. It's really just exactly the same. Let me show you another more interesting example. Okay, I don't want to do that. You go away. So let's look at something a little more exciting. And this is called object serialization. Get rid of that. Get rid of that. I don't want to confuse my life any more than I have to. Okay, so let's talk about object serialization. This looks terrifying. It isn't. All right, I think I have a better demo of that somewhere else, but we'll go with this. All right, so in this particular class, in this particular project, I have two classes. You can have two classes in the same file, but only one of them can be public. That's going to be the main class. But if you look down here, I have an old friend. I've created the critter class. Okay, and we'll see what happens here with this critter class. All right, so it is a class. Now it implements serializable, whatever that means. We'll come back to that in a minute. It has two properties, a name and an age, and it has a constructor where it passes the name and the age. Okay, so that's a pretty simple class. Doesn't matter, the class can be as complicated as you want. The interesting thing here is that it implements this thing called serializable. Now in this case, serializable doesn't require me to do anything else. It's just a marker on this class that says, I promise that this thing can be serialized, whatever that means. And I'll explain right now what that does mean. So in my serial demo, I save the critter and I load the critter. Now here's the thing. Much of the time in Java, you're not going to want to save stuff as just plain text files. That's too complicated. Most of the time in Java, you're storing your data as objects, or better yet, as arrays of objects. Yeah? And so here's the really, really cool thing, is that this serializable interface, what that means, this principle of object serialization, is a technique built into Java that allows you to save an entire class instance, no matter how complicated it is, with only one line. And that's really, really handy because rather than trying to figure out how to save all the data in a critter, I just save the critter itself. And so for many of your final projects, this will be your preferred data storage mechanism, especially because we're not going to talk about SQL this semester. So let me show you how it works. Here's the save critter. First, I just make a critter. Okay, that makes sense. And so there's my critter object. Now I'm going to do some file I/O. So once again, I have to do an exception handler. Now I'll do file output stream faux. This is a new file output stream. That's another form of connection we can attach to the hose. You okay with that? I'm not going to call it texts. I'm going to call it dat. Let me change it down here too. The reason I prefer calling it dat over texts is that this is not going to be an ASCII file. It's not going to be a file you could open up in Notepad and expect to be able to read. So dat implies that it is binary data, which is true. Let's save this. Okay, so I'm going to create a file output stream called serialcritter.dat. And now, attached to that, I'm going to make an object output stream. Yeah, I'll never remember that. That's okay. You can just take this code. You can reuse this code. I do. Once I've got that, now there's a write object method that allows me to pass an instance of a class. And as long as that class has implemented the serializable interface, then I can serialize it. I can use this technique to save it. Oh, okay, that makes a lot of sense, doesn't it? So now I can write the object. And the cool thing is that it will preserve the structure of the object. So I'll see all of its properties, I'll see all of its methods. I can save any instance of an object with this thing. And of course, if I have 10 instances objects I want to write, I can write them all. Just have to keep track of the order of them. So then we catch an exception and print it out if it happens. Well, that's pretty cool. We also have a load critter, which of course is related. So for the load critter, the first thing I do is I have to create an instance of my critter, but I'm not going to instantiate it. I don't need the constructor here because I'm not going to build it. I'm going to read it in from the file. So now I have an analogous situation to how I wrote stuff out. I'm going to have a file input stream. It's the same one. Again, I'm reading the data in now. Now I'm going to create from that an object input stream. And now I'm going to do object in.readObject. Now, Java being Java, you always have to know what type of data a function returns. Well, that's a problem here because we don't know what kind of data necessarily, or the serializable interface doesn't know what kind of data it is. So what the read object does is it returns an object. Remember, the object is the parent of all classes, right? So in Java, if two things are in the same family tree, we can cast between them. So I'm going to take the object that gets read in, and of course it's in the same family tree as object, so I can cast it to critter and then store it to my critter. Oh, okay. Now we can just prove that it got there by printing out the critter's name. And we'll take a look at this and see how it goes. Let's run it. Compiled, run, Lizzie Borden. It worked. Okay, super. Good grief, I'm getting lots of emails too. Let me get rid of that too. Mail, close. Don't bother me, people. Teaching my friends here. All right. So there's object serialization. Does that make sense? Sometimes when you run into serializable interface, you will see this error message, especially in Eclipse. All right, so when you're looking at serializable interface, you are supposed to also include, where'd it go? That's not helpful. When you have tried to write, say, a Java JFrame, it may have complained about the fact that you didn't have something called a serial user ID or something like that, or a version ID. And that's because the interface wants you to do that. Now it's not going to hurt you not to. The reason that's so important is that a lot of the objects already built into Java already implement this serializable interface, which means you can save them. That's really interesting. So anything with the serializable interface can be saved, including an entire JFrame. So your entire program, if you want to be able to save everything, you know, a running version of your program, you can use that interface. What else is truly interesting, and we could try it, is that you can do a whole, I won't do it here, but I'll show you. So any object can be saved, right? But what about this? Could we save an array of objects? And the answer is yes, we can, because an array of objects is serializable as long as each of the objects it contains is serializable. And that turns out to be incredibly useful, because what we could do now is we could make some sort of a program, right, that stores a bunch of data as an array of an object type, and then we can store that array in one swoop and load that array in one swoop. And that means we have a very efficient and powerful way of mechanizing our data storage. So does this stuff make sense? Because now I'm going to turn the corner. You okay?
Yeah.
All right, excellent. So now I want to start talking about putting together a much bigger program, the sort of thing that you might be doing for your final project. So we're going to talk about that a little bit today as you're going to start doing final projects. So I want to show you sort of how we start thinking about something larger. So here's sort of a sample thing I would like to have. So I'm going to make a program that would allow me to do a quiz. I'll go ahead and run it for you so you can see it once, I suppose. And then we'll learn how to write it. Now, typically, you don't see a program before you write it. That's why you have to write good documentation. Yeah, I think this version will work fine. Save it with serial, compile, and run. Okay, so this thing is a little program that creates a quiz. So we look at the quiz, and it asks us some good questions. What is 2 plus 3? Well, that would be 1,000. No, keep trying. That would be banana. No, keep trying. 5. You're very smart. Okay, so that was good. Man, I hope the test is this easy. What country? Now, I wrote this class in China one time. So what country is Changzhou in? It is in the United States? No. Mexico? No. China. Hey, you're very smart. What's the worst kind of joke? Knock-knock jokes. Clearly, you're very smart. What is snow like? You guys might not know this one. The best variable ever. Keep going. We love keep going. And so on. So we can make our little quiz. Now, what's interesting about this quiz is a lot of things. First of all, you're seeing the same user interface over and over again. The user interface doesn't change. I'm not writing a new frame for each question. What I'm doing instead is I'm reading the questions out of a very simple database. And I have a mechanism that allows me to go backwards and forwards between the questions. And I can do some other interesting things with it. So it automatically seems to be able to display a question. It can read the answers. It can check against the correct answer stored somewhere. And it should be able to do more, like keep track of how the users did and so on, but I don't have that built in yet. I'll leave that for you. All right, so let's take a look at how this thing is designed before we worry about how it's written, because writing the code isn't actually the hard part here. The hard part here is understanding what it is that you're trying to do. And so the first thing that you do when you're going to build a program like this, or really any kind of program, the first thing to do is actually to think about the data. And so as I'm looking at this program, before I had it done, I had to ask myself some questions. How would I make a program do what I want this thing to do? And so the first thing I thought about was, what is the data? And again, I'm not too concerned about whether, how I do it in Java, because frankly, I've done this in about 10 different languages. Doesn't really matter. What I'm thinking about now is, what kind of data is a quiz program really about? And this one's quite simple. So its data is about, I said, problems. And a problem contains these things: a question, an answer A, an answer B, an answer C, and a correct answer, which is going to be the letter A, B, or C. That's how I decided my data was set up. And then this little stack thing means, well, I've got a bunch of them that are the same structure, but will have different values. So that's the key data structure in this program. Pretty much every program I've ever written, including games, are really databases. Now, just because it doesn't have to use SQL and stuff like that to be a database. We can do that, but any program that works with data is a database, and most programs work with data. So the first thing I want to do is understand the key data behind my program. When I know that, now I can start to think about some other things. Now, another thing you may do is you're working through a project, and I'll ask you to do this, is to think about who are the users of your project and what will they do with it. Now, for this very simple version, I'm only going to have one kind of user. I'm going to have a student who is taking the test. But that means that this is not really complete, because what should I also have? I should also allow a teacher who can make new tests. That would be good. Or who could grade the tests that the students have taken. But for now, I'm just going to have a student whose job it is to take the test. The student will not need to log in. I'm not going to keep track of their progress. Why? Because I'm leaving that for you. If you want to make your own quiz program, then those are the sorts of things you would add to this. All right, so once we think about that, now we think about who our users are and what problems they are. And for each of those users, we might just start diagramming what the screen looks like for them. Now, I'm not really at all interested in things like what colors are we using or how pretty is it. What I'm interested in right now is, what kinds of elements am I going to need on the screen? How are they going to relate to each other? What are they going to do when the user interacts with them? This is incredibly useful. And if you're doing a GUI in Java or any other language, you really need to have this diagram before you start writing code. And the reason is, this diagram and the data diagram, they turn out to be the code. They actually are the code. It's just a easier, more visual way of seeing the code. So if you take a look at my diagram, you can learn a lot from it. You can see that I'm going to have a label for the question. Notice this is pretty closely related to my data structure. That's not surprising, is it? A button A, a button B, a button C. I don't have a button ants. Why not? Well, we're not going to tell them the answer. That would make it too easy. It's important that I specify some things are labels and some things are buttons. Because code-wise, although they're different elements, the more interesting thing is that labels never have to worry about events. So I'm not going to ever attach any code to a label. I'll definitely have to attach some sort of code to my buttons, right? Because that's what buttons do. They sit around and they wait to be clicked. So that's interesting. We'll come back to what code happens on these. Now, I also seem to have another area where I can back up and go forward, and I have a counter which tells me which question I'm on. I may need some other kind of output for feedback. Hey, you did great. You did terrible. Okay, so that makes sense. Now we look at this a little bit, and you might write it down, or you might just recognize, oh boy, how are we going to do that layout? So when you look at that, now you say, okay, I've seen some layout things here. Actually, to me, this one looks pretty obvious. It looks like I have a grid layout with two panels. A border layout with two panels. In the center, I could do a grid with one column. In the bottom, I could do a flow. And when you get more experience, you start to just see that stuff. So, okay, if you're not sure, you write that down. So you say, okay, that's how I'm going to put this stuff together. I think I know what goes where, maybe even diagram that out a little bit. Now, for every button, you need to have some kind of algorithm, because every button's going to get clicked, and you need to tell yourself what's going to happen when they click a button. If you don't know what's going to happen when the user clicks a button, you shouldn't have that button there. Because, you know, the only reason to have buttons is because the users are going to click them. So what are we going to do? Well, I'm going to call check ants with appropriate guess. And check ants is going to compare the answer to the actual correct answer of the current problem. Okay, that makes sense. What'll previous do? Well, I'm going to decrement this counter. Clearly, the counter is important. Somehow the counter tells me which question I'm in. So we're going to decrement the counter. We're going to check for boundaries. We're going to display a new problem. What happens when they hit the next button? We're going to increment the counter, check the boundaries, display a new problem. Okay, that implies some interesting things. Probably I'm going to have a display problem function because I'm doing that twice. Also, I've got this other variable that seems really important now that wasn't in my data structure, and that is a counter to tell me which question I'm on. So by doing these two diagrams, I have a massive amount of information about what my program is supposed to do. And you are absolutely crazy to start writing a program by turning on your GUI or turning on your coding platform and starting to type code. That is insane. Draw it out. You don't have to use a formal drawing program. You can do it with pencil and paper. I don't care, but you need to have this kind of diagram in order to have any chance of getting a complicated program solved. Does that make sense? Now let me show you how I go from these two diagrams to actual code. First, we'll take a look at this one. The first thing I wrote was not the thing users see. The first thing I wrote was the data. So when I got a feel for this, now I'll come on over to my program. Now I could do it in a separate Java file just to make it easier to give to you. I did it as a single file. There is my problem class. Not there. Keep going, keep going, keep going. Sorry, it's moved around a little bit. Okay, so I'm creating a problem class. It implements serializable. Why? Well, because I'm going to want to save and load these things. Now, officially, when you do serializable, you're supposed to do line 211. Serial version UID. What is that? That looks terrifying. Well, it's fine. You want to give it a version number, and that's important because let's say I write this program and it's all going great, but then I discover I want 4 questions. I mean, I want 4 answers per question. It's like multiple choice. Well, suddenly anything that I stored with the last version is not going to work. So if you create something you intend to be serializable, you have to give it a version number. So if you change the data structure, you can keep track that, oh, this is not the same version. That makes sense. Now we're not going to change it. If we do, we're just going to kill old data. So it doesn't matter too much, but you will get a little bit of a warning in Eclipse if you don't put a serial version UID in a serializable object. So it's a good thing. It's not going to hurt anything anyway. Now, I'm going to make each of my fields private instance variables, and I'm going to make them all strings because that works for me. Now, I'm a little lazy here, so I am going to do getters for everything, but the only setter will be the constructor. So there's my constructor. I take in all of this stuff, and then I copy it on over to my instance variables. And now I'm going to have getters for everything so I can get all of these things out of there. So do you see that this is equal to this? See, they're really the same thing. When you look at these things, that is that. And I didn't have to guess when I'm writing this class. I'm looking at my little diagram and say, oh, I know I need all these things. Now I just need to think, how am I going to get access to them? Does it need to be more complicated than that? I'm expecting to save them, so I'll make it serializable. So there's no guessing. I have a diagram. I go from the diagram. I know how my data shows. Now, same thing is true of the user interface. So I look at this, and I have a really good idea what my user interface is going to be. I'm going to look way back up at the top, and you'll see that seems a touch more complicated, but it really isn't, because once again, I've made all the hard decisions before I started coding. And you know this, right? You started writing some code, and it's tricky, isn't it? It's hard. It's even harder if you don't know exactly what it is you're trying to accomplish. So we want to separate those tasks. Make sure you know what you're trying to do, then try to do it. So the good news is when I'm making this whole J-frame now, it looks like it needs to be a J-frame. I know exactly what my components are going to be. LBL question, button A, button C, button next, button prev, label counter, label output. That one wasn't in my diagram, but it looks pretty important. So that's pretty sensible. Those I could see. After some analysis, it was clear that I would need a counter. Now, one more thing that doesn't show up here in the visual interface is that, hey, I'm going to want an array of problems. That's how I'm going to actually control this data. So I'll have an array of problems. Now I'm feeling very good about my data and my UI. So I kind of know how things are supposed to flow. And then building the whole thing is pretty straightforward. I don't know why that indentation is weird. I'll fix it. I move around between editors all the time, and Eclipse in particular seems to mess things up sometimes. So you can see in my constructor, I'm just calling all the other functions to separate my thinking. As soon as I start to do something complicated, I break it into smaller steps so that I can test each step on its own. So create the parent class, set up the GUI, register the listeners, save the problems, load the problems, update the screen. Sounds pretty fun. Let's see how this works. So setting up GUI. Now the only problem I'm worried about is just getting the visual look right. I don't care if anything works yet. I just want to set it up. And as you can perhaps guess from the diagram, it's pretty straightforward. So I'm going to have a panel containing the question pieces. That's going to be this part. And I'll have LBL question, button A, button B, button C. So that's all making plenty of sense. So the J panel is going to be a panel. It's going to contain these pieces. Now I'm going to make another panel for the controls. That's going to be this part at the bottom. It's a new J panel. It's going to have a J button for back, a J label for the counter, an output to give some interface, some feedback to the user, and a forward button. Okay, that's all good. Now that I've got all these pieces created, now I just put them together. So panel question, set yourself to a grid layout of one column, any number of rows. Add these things to panel question. Panel controls, we'll set it to a flow layout, add everything to it. Now we set up the main layout. We'll make that a border layout, and we'll add the question to the center and the controls to the south. And again, this was pretty straightforward. In fact, I didn't have to do a lot of thinking. All I had to do was remember, how do I implement the idea that I've already come up with? And that's really the key to writing a more complex program, is you begin by having a diagram and understanding what you're trying to do, and now you're simply implementing those ideas. Then, of course, I do the things I always do: set its size, set its visibility, set its closing operation. And at that point, you can run it. You can run this thing and see, is everything working? In fact, typically I run it with just a few pieces on, just to make sure that I'm headed in the right direction. Okay, that's great. So, excuse me. So the next thing is to register the listeners. Okay. Well, that should be pretty easy, and it is. Every time we have a button, it needs to be connected to some kind of action listener, right? Well, here's the good news. If we look at our original class, we've designated it to implement the action performed, so we can listen to all of our own actions. So I'm just going to tell everybody, hey, action performed is here. So every button's going to go here to look for action performed. Terrific. So that means, of course, we have to write one. All right, now save and load problems. Now this can be done a couple of ways, but the way I did it here is I simply preloaded these problems in. So I could make new ones. You know, if you'd like me to do this one, what country is Marco in? And we'll replace China with Nicaragua. Didn't change the truth of it. Okay, so we can change this stuff. So here I'm simply making an array of problems. And then what's happening here? Take that, save it out to a problem list. Now, why bother with this? I don't really need to save it, right? Because it's already in memory. But here's the good news. Down the road, what I might do is make a totally different program that's an editor that allows me to save new problems. That would be just a wonderful idea. So a lot of times I'll preload some data into my program, but really I don't want to use that. I want to be able to save and load problems so I can use the same program to write a lot of different quizzes. And so this is going to save that whole array out. Now I'll be able to load an array in. Now in this case, I'm loading the same array I just saved. Normally I'd have some interface where they can choose from the file chooser or something and find a test file and load it up. But I will leave that as something that you can do if you want to rebuild this and make it fancier. So save and load, that was pretty easy, really. Typically, when we save, we're not going to pre-build a set. We're going to take whatever was here, but that's fine. Now, action performed. Remember, all of our buttons came to the action performed method. And so what's going to happen here? Well, now we're just going to check to see which button got clicked. If you're not familiar with some of this, make sure you've reviewed the videos because I've covered all of this stuff. There's a lot of material. So now we're going to check the source to find out which button got clicked to get us here. And if it was button A, we're going to call check ants and pass it an A. If it's button B, we're going to call check ants and pass it a B, and C, and pre, and next. So each of these buttons is simply going to pass control off to one of our other functions. Now this else clause happens in case some other thing happened. It shouldn't, but it might. Now we'll just write those. So check ants, its job, well, is to check the answer. So we've passed it in a guess, A, B, or C, based on which button the user clicked. You might be tempted to put a different function for each button, but that's too much work. We'll just pass in a parameter. And so now what we'll do is we're going to take a look at our problem list. That's that array of problems. Subcounter, that's which problem. And find out what we stored as the correct answer. That's going to be a capital A, capital B, or capital C. So if the user's guess is equal to the correct answer we pulled out of the database, then we tell them you're very smart. Otherwise, we say keep trying. Make sense? So then previous question is we back up one question. So counter minus minus. If counter is less than 0, set it to 0. Update the screen. We'll see what that does. But what that does is based on the current status of the counter, it loads up from the database and puts the questions on the screen. Next question, go forward if possible. Remember, every time you change a variable, you should look for boundary conditions. So once we increment counter, make sure it can't get too far past the length. Now the update screen is pretty straightforward. Given a counter, it's going to go find the appropriate problem from the problem list database. Now it's going to use those getter methods to get the data. So get the question out of P and set it to label question. Get answer A out of P, set it to button A, and so on. So this function simply updates the screen based on the current counter. And then we've got the problem, and believe it or not, we're done. That's very, very powerful. And when you see the way that we put the whole thing together, it isn't that crazy. Let me resave it. We should do the San Marco question. Okay, 2 plus 3 is indeed 5. Moving along. What country is San Marco in? That's in Nicaragua. Oh, hey, I'm smart. Knock knock jokes are horrible. Snow is cold, and keep going is the best variable ever. Okay, so that's pretty good, right? Now, here's the deal. I'll go over this a little bit more next week, but I'm going to stop having homework assignments. Yay. Yeah, you woke up for that one. So what we're going to do from here on out is I want you to write your own program. And I'll give you a little bit of an overview of it. I'm not going to spend a ton of time because we're almost out of time, but start looking this over. And basically what you're going to do is you're going to write your own program that does something interesting. Now, if you'd like it to be based off of this quiz, this is fine, but don't turn in my quiz. We already know I can write Java code. So you got to write something of your own. So please take a look at this, get a sense of it. You won't be shocked that I'm looking for a data plan and a system overview and maybe some user interface design. And then there's some more things about how exactly you're going to do it. So for next week, I want you to be thinking about how to do this. You still have some time to write your the last project, the BMI. But then from the rest of the semester, this is what we're going to work on. Sound good? Now, what is your schedule like? So we're on Thanksgiving this weekend. You guys don't do that there, right?
Yeah, we do.
Oh, you do?
Yeah.
Did you meet last week?
Yeah, but
okay. Well, you saw the video, so we're good.
Yeah.
All right. You guys are awesome. Have a really safe and happy break, and I will see you next week. Thank you.
Thank you. Bye-bye.